Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we are going to write a program that is going to calculate and print the squares of the integers from 1 to 10 using a function called square. Now let's go and run our program. Now you can see that our function was not recognized and we got an error. For that we need to define the prototype in here. So let's go and enter the prototype. And let's bring this function out of the main function. Now as you can see, we have got our results and we have got the square of 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. In the coming episodes, I'm going to explain each lines of this code one by one. So stay tuned for the coming episodes. Hello and welcome to this episode. As you remember from the previous episodes, we wrote this program and we used this function called square function. Now we have used this square function to print the value of a square of x in this line of code. Now in here, basically we have called or invoked the square function. When you want a function to do something, then that is calling the function or invoking the function. Then you will provide an argument to that function. In here we have provided the value of x. Remember that the function square receives a copy of the argument's x value. That means that the original x value will not be manipulated and only a copy of this value is going to be sent to the function here so that the function can do its calculation based on this value and return some other type of value. Hello and welcome to this episode, and in this episode we are going to go and discuss a little bit about the definition of the square function. So as you can see in here, we have the square function all by itself in here, and the whole square function is noted in here. Now let's go and discuss about this part, the arguments of the square function. So the argument of the square function expects that we give the square function or we provide the square function with a number, and the type of the number should be an integer. And the preceding keyword that we have before the name of the function, this means that this function will return a value and the type of that value is going to be an integer. As you can see, we have the return statement in here, and what we are going to return, that is number times number. Basically this is going to evaluate to a value, and that value is going to be returned by this function. The type of that value is going to be an integer. Also, it's very important to choose meaningful names and meaningful parameters for a function so that you don't have to provide a lot of comments to elaborate and explain the functions. As you can see here, we have the name of this function as square. That means that it will provide the square of any number that you provide to it. It will provide you with the square of that number. So the name of the function is meaningful, and also the name of the argument is meaningful. Also remember that when you are writing a program, the program should be written as a collection of small functions, and it should be divided into so many small functionalities and functions, and each functionality should be written as a small function. Also remember that if you have a function that requires a lot of parameters to be provided for the function, that means that this function may be performing too many tasks at once, and that's why it's always a good idea to consider dividing the function into smaller pieces and into smaller functions that perform separate tasks. And basically this is the whole idea about functions, that is to divide and conquer any complex task into smaller pieces. That's it for this episode. I hope to see you in the coming episode. Hello and welcome to this episode, and in this episode we discuss the local variables. So what do we mean by local variables? All variables that are defined in functions definitions are called local variables, and they can be accessed only in the function in which they are defined. So as you can see here, we have the function square in here, where we have defined this variable in the parameter of this function. This or any variable could also be defined here in the body of the function, and that will also be called a local variable, either in here or in the body of the function. They are called local variables, and they are only accessible inside the function. They're not accessible when you go outside of the function. For example, if I try to print the number, which the number is a local variable for this function, it is not available for me in the main function. So here in the main function, if I try to print the value of number, let's go and try this. And as you can see, the number is undeclared here in the main function, and it's not possible for us to access this variable outside of this function. Now if we try to bring this statement inside of this function, let's go and execute. Now you can see that yes, we have been able to print the number here in this function. As you can see, we have 1 and the square of 1, 2 and the square of 2, 3 and the square of 3, 4 and the square of 4, 5 and the square of 5, and going on like that. And that's it for this episode. I hope that you've got a good understanding of local variables, and I like to see you in the coming episode. Hello and welcome to this episode, and in this episode we are going to discuss about the function prototype that we used of the square function. Here we have the function prototype, and the function prototype is important because the compiler uses the function prototype to compare the call to the square function to its prototype, and it's always important to consider that the number of argument is correct between the function prototype and the function definition. Also, the argument types are correct, so if we have an integer in here, it should be an integer in here as well. And the argument types are in correct order, so if you have more than one argument, you have to make sure that their types are in correct order. And the return type is consistent with the context in which the function is called. So in here, if we have a return type of integer, we need to have a return type of integer in the definition as well. And lastly, don't forget to add semicolon at the end of a function prototype. As you can see, we have a semicolon. And if you don't add the semicolon, there will be a syntax error. And that's it for this episode. We will be discussing prototypes and function prototypes in more details in the coming episodes. So stay tuned. Hello and welcome to this episode, and in this episode we are discussing the format of a function definition. As you can see, this is the general format for a function definition. We have the return value type, then the function name, then we have the parameters list, then we have the opening braces, we have all of our statements inside the function, and we have the closing braces. A few notes that I want to tell you in this episode is that the function name can be any valid identifier. So here we have the function name, and this function name can be any valid identifier, and we have discussed about identifiers in the previous episodes. So let's go and, as an example, define a function of our own. First, we will have the name of the function that will be a valid identifier. For example, we want to have a function which is finding the cube of a number. Okay, the second point that we want to discuss about is the return type. The return value type is the type of the result returned to the caller. So in here we are going to define that after the function has finished its calculation, what is it going to return? And what type of data is it going to return? For example, we are defining that our cube function is going to return an integer. The return value type void indicates that a function does not return a value. So instead of integer, if we had void, that means that the function will not return any value. But in our case, it does return a value, and that is an integer. Now together, the return value type, the function name, and the parameter list, which is basically all of this part, they are sometimes referred to as the function header. So basically this part in total is called a function header. The parameter list is a comma-separated list that specifies the parameters received by the function when it's called. So as you know, we have the parameter list in here, and in here we are going to define the parameters that this function needs. Basically, parameters are those informations that this function needs to receive to be able to perform its task. For example, for our cube function, we need a number to be given to the cube function so that it calculates the cube of that number. Now in here we are going to define a parameter that the type of the parameter is going to be an integer, and the parameter itself is going to be a number. And in fact, this function could receive more than one parameter. So there could be that we separate these parameters using a comma, and then we define another parameter, for example, a type double. And this double is going to be some other type of value. But for our cube function, we don't really need that. But you need to know that we always use a comma in here to separate the parameters from each other. Now, if a function does not receive any parameters, the parameter list should contain the keyword void. So in here, if we are not giving or providing any value to our cube function, then we have to write void. But no, in our case, we do need to provide a value to the function cube, and that's why we will put our parameter, and that is a variable with its type. As we said in here, each parameter must include its type, otherwise it is a compilation error. So you need to provide the type of the parameter that you want to provide to this function. Placing a semicolon after the parameters list right parentheses in a function definition is an error. For example, if you put a semicolon in here, this is going to be an error, and in fact you have to put braces and not semicolon. Also, we want to discuss about the fact that redefining a parameter as a local variable in a function is not incorrect, but we do not recommend it because it creates ambiguity. For example, we have this parameter called number in here, and in fact we can create another variable inside of the function that will be of, for example, type double, and or even it could be an integer as well, and it has a name number. Now this number is going to be different from this number. This is a parameter and this is another variable, but we do not recommend this, and it's not recommended to do this because it will create confusion and ambiguity for the program. So instead of a number, change this variable name into something else that could be more specific, and it could be different from this parameter name. Now the statements within braces form the function body, which is also called a block. These statements that we have inside of this braces, one opening braces and one closing braces, this is called the body of the function, and it is also called a block of code. Functions cannot be nested, and defining a function inside another function is a syntax error. So basically that means that inside the cube function I cannot create another function in here, and it has to be outside of this function. And that's it for this episode. I hope this has been helpful and informative for you, and I would like to see you in the coming episodes. Hello and welcome to this episode. In this episode we want to discuss about returning control from one function to another. So for example, I have the main function in here, and this function has called the function cube. Now the control has gone from a main function to this function. Now the control is in here. There will be three situations where the control will return to the main function back once again. So what are those three situations? First, the situation is that this cube function starts to execute, and it will continue executing until the last statement, and then there's no other statement, then there is the ending braces. Now automatically the control will be sent back to the main function, and these statements after the cube function will start executing. Now the second scenario is that you will have a return statement. For example, we have a return statement in here. Now this return statement will return the control of the program to the original function that was calling the cube function. And that's basically the job of a return keyword, to return the control from one function to another. And specifically, if there was a value in here, this function was returning a value, the control of the program will be transferred to this original function, and also the value will also be returned to this original function that it was calling this cube function. And basically these were the three situations where the control of a flow of the program will go from one function to another. And that's it for this episode. I hope to see you in the coming episodes. Hello and welcome to this episode, and in this episode we discuss the main function's return type. Now you might have noticed and you might have seen that in many functions that we write and in many programs that we write, we have this return 0 at the end. So what does this return 0 means at the end of this main function? It basically means that the main function executed successfully and there was no error happened in the function. So basically it means that if the control of the function came up until return 0, that means that the main function, the execution of the main function has been successful. So that basically indicates successful. But we can also have conditions. For example, we have specified inside of the function a condition, and this condition says that if an unexpected result happened, some type of error happened, or some type of unexpected result happened, so what you're going to do is that you are going to return -1. And this -1 indicates that there was an error in the execution of this main function. And that's basically, I wanted to let you know that return 0 always means a successful completion of the main function, but any other value could be defined as something else. -1 could be defined as error or any other situation, not only error, it could be any other different types of situation that you can define as well. But 0 usually means successful. And that's it for this episode. I hope to see you in the coming episodes.